Assalamualaikum warahmatullahi wabarakatuh. To my fellow panel, I hope everyone is staying safe during this pandemic. My name is Shahir bin Salleh and I'm under supervision of Dr. Nurul Hayati Binti Abdul Halim. In this video, I'll be presenting about my study in storage system for effective material handling in mechanical workshop. The agendas for this presentation are: first, quick and simple introduction about the project; second, project methodology; next, result and discussion; lastly, recommendation. For your information, this study is based on site study which conducted in the Advanced Machining Lab UiTM Shah Alam. The targeted area that was tackled in this study was material handling system. In this project, I'll be designing a new storage system which could improve the existing system. The problem statement are long time taken to loading and unloading material. It is because the process done was manually insert material one by one into the storage. It is also requiring more additional manpower to complete the process. In the other hand, the area looked disorganized and dangerous to other users. The objective of this study are to identify and eliminate waste as well as to design a new storage system by using CATIA V5. Also, to identify an optimal design based on its functionality, reliability, and cost. The working space in this study were done by first literature review on lean manufacturing and Toyota production system, and also material handling system. Second is create conceptual design and design criteria. Lastly, develop the project methodology. The first methodology is identify the existing storage system. As you can see in the picture, I have identified that the existing storage was bulk storage with improper handling and storage system. Some of workpiece disorderly placed in the ground as the rack was congested with other material. Because of this, it required more space in the lab. It also collected information on the material which come with different sizes and type of workpiece, either in solid block or cylinder or in long metal sheet. The second project methodology is conceptual design. Conceptual design is an important activity in the design process. It is constantly being emphasized that incorrect conceptual design may lead to expensive rework and problems that may happen after the product is fabricated. There are two product design that was introduced in this project, which is metal bar storage rack and trolley metal storage rack. I started my conceptual design with sketch design. These are the ideas that I generate for this project. Next is the performance decision metric that has been evaluated in this project. There are 6 criteria that have been considered in this project, which is durability, mobility, safety, ergonomic, easy to use, and affordable. As shown in the table, for the metal bar storage rack, the option 3 has been selected for this project because it has the highest net score among the other options. Meanwhile, for the trolley metal storage rack, the option 2 has the highest net score, therefore was selected for this project. Lastly, the metric of requirement design specification. The metric chosen was mild steel. It is because the price of mild steel is a lot cheaper than others, and it is also high wearable compared to other steels. The ergonomic zone for the average of Southeast Asian is around 730 to 4035 millimeter. Other than that, the maximum load capacity for the metal bar storage basket is 2000 kg per each basket, while the max load for the trolley metal storage basket is around 30 kg per each basket. The bracket max load capacity is around 50 kg per each row of the basket. The third project methodology is 3D modeling. The conceptual design will translate into 3D model by using CATIA V5. For metal bar storage rack, the 3D model consists of 3 main parts, which is frame, basket, and roller. The storage was designed to have 5 tiers basket, which allow to store different type and sizes of the material. It is also has slotted part for the basket, which allow to separate the material and organize the material in a more efficient way. The bearing used in the roller was the double bearing. This allows smoother slide of the basket and also require less force to pull or push the basket. For the trolley metal storage rack, there are various sections in one product, which is bracket, basket, lower bracket, and middle section. The aim for this variety section is to store different sizes of the material in more organized way and also to minimize space taken in the lab. The fourth project methodology is finite element analysis. In this study, CATIA was applied to conduct finite element analysis of the rack system. Welded joints are used to presume a relationship between the component. By merging the component into a single design, the welded joint were defined in CATIA. It was done by presuming there would be no connection failure during the analysis. To put it another way, a welded joint is a perfect joint. This method has the advantage of saving labor time and reducing error during static analysis. In this study case, has been used size and sag of 25 mm and 5 mm respectively for the meshing. For the metal bar storage rack, the FEA was performed by using distribution load of 2000 kg per each basket per row. The load of 2000 kg is converted into Newton according to the load unit requirement on CATIA. If 1 kg equal to 9.81 Newton, then the load given is 19620 Newton. Meanwhile, the distribution load for the trolley metal storage rack is slightly lower than the metal bar storage rack. For the bracket section, the distribution load applied was 981 Newton per row. For the other section, the distribution load was used 294.3 Newton per each basket section. As for the result and discussion, for the metal bar storage rack, the von Mises stress and the translation displacement in the most exposed location, as shown in figures, was determined. The frame maximum von Mises stress and translation displacement is 6.97 exponent 7 Pascal and 0.491 mm respectively. Then, the factor of safety for metal bar storage rack frame is calculated as follows. Secondly, the maximum von Mises stress and translation displacement for the basket, which are 1.66 exponent 8 Pascal and 6.51 mm respectively, as shown in figures. The factor of safety for basket storage is calculated as follows. The factor of safety value obtained for both frame and basket are greater than 1. This means that the design is suitable for use of the intended purpose. For the basket part, it can be said that permanent deformation will not happen until the maximum of 3000 kg. Therefore, the structure of this basket is safe to withstand the maximum load of the design, which is 2000 kg. Moving forward to the second design, the maximum von Mises stress and translation displacement is 4.6 exponent 7 Pascal and 0.485 mm respectively, as shown in figures. The factor of safety for trolley frame is calculated as follows. Based on the factor of safety obtained, which is greater than 1, it means that the structure of trolley frame is safe to use for its intended purpose. Lastly is the estimation cost of the material. The grand total estimation cost for the metal bar storage is 7,360 ringgit and 1 cent. And the grand total estimation cost for the trolley metal storage rack is 1,084 ringgit and 24 cent. The total estimation cost of the metal bar storage rack is more expensive than the cost of the trolley metal storage system. This is due to the fact that the basket in metal bar storage rack require a good bearing quality in order to serve the purpose of moving the basket that will carry the max load of 2000 kg. This cost is acceptable and considered affordable compared to other ready-made storage rack. For the recommendation for future work, I would like to recommend adding RFID system for the best monitoring of material in and out through software. Also, add sensor to detect empty basket, which could maximize the productivity. They would very much help to alert the lab technician about the inventory stock. I think that's all from me. If you have any question regarding my project, please don't hesitate to contact me. Thank you for your time.